Hello, hi everyone. Welcome to the Student the Brand. This is Vatsva sir from Student the Brand. Today we are going to discuss about magnetic effects of electric current. Magnetic effects of electric current. CBSE Grade 10 Physics. Magnetic effects of electric current. CBSE Grade 10 Physics. Okay. So now we'll discuss. Magnetic effects of magnetic effects of electric current. So by passing the electricity through the conductor, by passing the electricity through the conductor, by passing the electricity through the conductor, so conductor will act, conductor will behave, conductor will produce magnetic field. So that is called magnetic effects of electric current. Magnetic effects of electric current. So in this live class, we will discuss completely about magnetic effects of electric current, and if the current is passing through the conductor, how it will behave, so how the field will be produced around it. So we are considering everything we will discuss now. And one more thing, magnetic properties. Magnetic properties. Okay. So natural magnet is there. Natural magnet is magnetite. Magnetite is a natural magnet. Magnetite is a natural magnet which occurs from earth crust, and artificial magnets are there. So like a bar magnet, U-shaped magnet, dumbbell-shaped magnet, cylindrical magnet. So like many are there artificial magnets. So we are discussing today about magnetic properties, and if the current passing through the conductor, okay. So how it will produce magnetic field, okay, around it, and how we are consider everything we will discuss now. Okay. So magnetite is a natural magnet which occurs from earth crust, Okay. So magnet has properties. Magnet has two properties. One is attractive property, another one is directive property. Okay. So that's enough. Now we will discuss about magnet properties. We'll discuss about magnetic properties. So one is I said attractive property or repel also, so it will repel, and directive property. Will discuss. Normally, if you are taking the magnet, so I'm taking the bar magnet. This is the artificial magnet. So I'm taking magnet has two poles. Okay. Magnet has two poles. Two poles. One is north pole, another one is south pole. North pole and south pole. So here, if you are taking this north pole and north pole, south pole, and north pole, south pole, and south pole, north pole. So here, these two will repel. So first one coming to the second one, third one, fourth one. So here also repel, and here attract, attract, and here attract, So we can understand by seeing this one. We can understand by seeing this one. Two similar poles. These two are similar poles. These two are similar poles will repel each other. Similar poles will repel each other. Similar poles. Similar. Similar poles will repel each other, whereas dissimilar poles will attract each other. Dissimilar poles. So dissimilar poles will attract each other. So will attract each other. So once again, similar poles will attract, similar poles will repel each other, dissimilar poles will attract each other. Okay, so I'm considering here, so you can take these two. You can observe north pole, those are two similar poles repel. South pole repel. North pole will attract. South pole, north pole will attract. Okay, so we can see that two dissimilar poles will attract, two similar poles will repel. Okay, and one more thing, okay, so here magnet has two poles. Magnet has two poles, north pole and south pole. North pole and south pole. Magnet has two poles, north pole and south pole. So two poles has equal strength. Two poles has equal strength. Equal strength. So equal strength. Hi Dolphin, welcome to the class. So being a member. So thank you so much. Being a member of the channel. So thank you so much for that. Okay, here I'm considering. So magnet has two poles. Magnet has two poles, north pole and south pole. Magnet has two poles, north pole and south pole. Okay. So here you can observe one thing. So carefully observe one thing. Okay. Carefully observe one thing. North pole, north pole, north pole. So if you are taking north pole will repel. South pole will repel. North pole will attract. South pole, north pole will attract. South pole, north pole will attract. But in this case, if you are observing, okay, so magnet has two poles. Two poles has equal strength. Two poles has equal strength. Equal strength. Equal strength. Magnet has two poles. Two poles has equal strength. Okay. And one more thing, so those poles are not at the end of the magnet. Those two poles, so here I'm taking north pole and south pole. These poles are not at the exactly end of the magnet. So they are little closer. So they're little inside. They are little inside. So exactly here. So it will be little inside, little inside. Okay, if you're dropping the magnet, if you drop the magnet into the side, what happens? So magnetic poles attract magnetic materials equally. Magnetic poles attract the magnetic materials equally. Okay, right? So magnetic poles will attract the magnetic materials equally. So north pole and south pole has equal strength. They attract the magnetic materials equally, right? Yes. And one more thing, around the magnet, magnetic field will be there until certain range only. It will attract the magnetic materials. Until certain range only it will attract the magnetic materials. It won't attract beyond the point. So I am taking here, so this is one magnet, so this magnet will attract another magnet up to a certain range. Up to a certain range only it will attract. Beyond the point it won't attract. So certain range, certain field. So within that field only the magnet will attract the another magnetic material. The magnet will attract the another magnetic material within certain range only. Beyond the point, more than that region, it won't attract. Okay, up to a certain range only the magnetic field will be there. The magnet will attract the magnetic material. Yes or no? So this is about a magnetic field. magnetic field and magnetic poles around the magnet. Magnetic field will be there around the magnet. Magnetic field will be there. Okay. So now here one more point. If you suspend the magnet, always it shows north and south direction. North and south direction. If you suspend freely, okay, if you suspend the magnet freely, always it shows north and south direction. So I'm taking the magnet like this. I'm taking the magnet here. So north and south, always it suspend. If you suspend the magnet, always it shows north and south direction. Not exactly at vertical position, somewhat tilted. So it will be a. So if you are suspending the magnet, somewhat it will be tilted, right? So like that I'm considering like this. Okay, so observe, yes or no, so that is about magnetic field, right? Now, so next one we'll discuss one more, that is, so till now we discussed about magnetic properties, magnetic field. Okay, so there are two. One is attractive property or even repel also, and directive property is suspend the magnet, always it shows north and south direction. Now we will discuss. So the main heading of the chapter you can understand magnetic effects of electric current. By passing the electricity through the conductor, conductor behaves, conductor act, conductor produce magnetic field. So I'm taking a straight conductor. I'm taking this a straight conductor. Okay, so the straight thick conductor I'm taking like this. Current is passing. So variable resistor I'm taking like this. Okay, we can consider like this. So switch, battery. So positive terminal, negative terminal, switch, current is passing. Okay, so this is a conductor, this is a cardboard. I'm taking the cardboard, this is a cardboard. This is a cardboard. Around this conductor, magnetic field will be produced. Because current is passing. Even if you take the iron nail if you consider, so I'm taking the iron nail. So iron nail I'm considering here. So you wound the copper wire around it, and connect to the battery. It acts as a magnet. So a current carrying conductor. So I'm considering here current is passing. Positive terminal, negative terminal, current is passing like this. Okay, so iron nail is there. If the current is passing through the iron nail, it acts as a magnet. Same thing. So here also I'm considering that one. If the current is passing through the conductor, it acts as a magnet. So it produces magnetic field around it. Okay, so if you are placing the compass around it, so if you place the compass, so I'm placing the compass here. If you place the compass is nothing but a small magnetic needle is small magnetic needle is there inside of it. A small magnetic needle. Okay, so it always shows north and south direction. So when the current is passing through it, so automatically it shows the deflection. So compass will shows the deflection. So when the current is passing, automatically it shows the deflection. By that, we can understand magnetic field will be there around the conductor. Surround the conductor if you are taking. So the magnetic field will be there. Here I am considering like this. Okay. So around the conductor, magnetic field will be. So in the form of concentric circles, so here I am taking like this. The magnetic field will be in the form of concentric circles like this. So closed loops. So closed loops. How can we identify the magnetic field? Yes, so it is CBSE grade 10 physics. Okay. So how can we identify the magnetic field direction around the conductor? How can you identify the magnetic field direction? By using right hand thumb rule. Okay. So if the current is passing downward direction, if you are placing the thumb downward direction, so the folding fingers represent the magnetic field direction. So around this one, the magnetic field will be there. Okay, so like this I'm considering. So this is the clockwise direction. If you're taking this is the clockwise direction, clockwise and anti-clockwise. So this is the clockwise direction, anti-clockwise direction, clockwise, okay, anti-clockwise direction, anti. So the magnetic field will be, because if the current is passing downward direction, so the magnetic field around the conductor will be in the clockwise direction. If the current is moving upward direction, if the current is passing upward direction, by using right hand thumb rule, we can identify the magnetic field will be anti-clockwise direction. The magnetic field will be so around the conductor in anti-clockwise direction. If the current is passing downward direction, the magnetic field will be around the conductor. In clockwise direction. If the current is passing upward direction, the magnetic field around the conductor will be in. So if the current is passing upward direction, the magnetic field around the conductor, will be in anti-clockwise direction. Magnetic field will be around the conductor in anti-clockwise direction. If the current is passing downward direction, the magnetic field will be around the conductor in clockwise direction. Okay, so that is about clockwise and anti-clockwise direction, right? So about magnetic field we are discussing. And one more thing we need to understand. So the magnetic field will be up to certain range only, I said. So near to the conductor, the magnetic field will be in the form of closed loops. The magnetic field will be in the form of closed loops. So those are concentric circles. Concentric circles in the sense around the conductor, the magnetic field will be in the form of closed loops. Concentric circles. Yes or no? Concentric circles. So as you move away from the conductor, the magnetic field will be less. So as you move away from the conductor, if you are moving away from the conductor, the magnetic field will be less. So near to the conductor, the magnetic field will be more. Okay, so the field lines will be more. The magnetic field will be in the form of closed loops. Okay, so the magnetic field will be more near to the conductor. If you place any conductor, any magnetic material, it attract easily. Okay, so the magnet around. So here I am taking the conductor. If I consider the conductor, okay, around the conductor, magnetic field will be there. So near to this one only, up to a certain range only, it will attract more. Beyond it. So beyond the magnet, beyond the conductor, so if you are moving away from the conductor, the magnetic will be less. So it depends on the distance from the conductor also. Near to the conductor, magnetic will be more. So away from the conductor, magnetic field will be less. Around the conductor, the magnetic field will be in the form of closed loops. Those are called closed concentric circles. Those are concentric circles. Around the conductor, the magnetic field will be in the form of concentric circles. Concentric circles. Is it clear? Is it clear? I hope it is very clear to you all. I hope it is very clear. Next one. So we'll discuss about, so this is about current carrying conductor, and one more thing, one more point I will tell you. One more point I will tell you, that is, so if the current is passing from top to down or north to east, so the compass will show the deflection. The compass will show the deflection towards west. Okay, so the compass shows the deflection towards west like this. Okay, so if the current is passing like this towards west, so if the current is moving, okay, so if the conductor is in reverse order, if you are considering, okay, so if you change the battery, so one more point also, if the current is changing, if the current direction changes, so current is moving upward direction, the compass should shows deflection towards west, towards west, towards west. Compass should shows compass deflection towards west, towards west. So if you're taking, okay, so current is moving along this line. So if you're taking clockwise direction, here current is passing in anti-clockwise direction. Current is passing in anti-clockwise direction. That's why compass will shows the deflection towards west. If the current is passing in anti-clockwise direction, if the current is passing in the direction of anti-clockwise direction, then compass will shows the deflection towards west, towards east. So this is the east, towards east. Compass shows the deflection towards east. So by this we can conclude one thing. By this we can conclude one thing, that is, if you change the current direction, the magnetic field direction also changes. If you change the current direction by changing the battery, so here initially the current is moving upward direction, now you are taking the current is moving downward direction. If you change the current direction, automatically magnetic field direction also changes. Once again, if you change the current direction, magnetic field direction also changes. Very, very important. So make a note of it. So this point is very important. Next one, magnetic field around the bar magnet. So we'll discuss about magnetic field around the bar magnet. So even this one also we can tell, current is passing through the straight conductor. Okay, if the current is passing through the straight conductor, how the magnetic field will be there, so around it. So this one we can write. So those who are new to the channel, so please do like, share and subscribe to Student the Brand. If you like the content, if you like the explanation, you can share to your friends, ask your friends to join to the class. So now we will discuss about magnetic field. Magnetic field around the bar magnet. Okay, so I'm considering here this is the bar magnet. North pole and south pole. As I said, around the magnet, magnetic field will be there. Around the magnet, magnetic field will be there. So how the magnetic field will be? So the magnetic field will be in the form of field line. the magnetic field will be in the form of field lines around the magnet, around the bar magnet. I am taking here bar magnet. I am considering the bar magnet. Around the bar magnet, the magnetic field will be there. So around the bar magnet, the magnetic field will be there. Okay. If you place any material, magnetic material, if you place any magnetic material up to a certain range only, it will attract. So if you increase the distance, so it won't attract. Okay. So the region around the magnet, the region around the magnet in which magnetic force, magnetic field exert. Okay. So around the magnet, around the magnet, around the magnet. Okay. So the magnetic field will be there in the form of field lines. So around the magnet, magnetic field will be there in the form of field lines, in the form of field lines. So the field lines are closed loops. The field lines are closed loops. So I'm suggesting you can take 5 lines or 7 lines or 9 lines. Okay, I'll draw the diagram. I'll draw the diagram. Okay, so I'll draw the diagram. Try to check it once. Hmm. So I'm taking here 5, 7, 9. 5, 7, 9. Okay, 5, 7, 9. Now you see. Okay, 5. Is it clear? You can take the magnetic field will be from north pole to south pole outside of bar magnet, south to north inside of bar magnet. So here I am taking like this 1, 2, 3, 4, 5, 6, 7. So first two you can add like this. So I am considering like this also. Mm-hmm. Okay. So magnetic field you can take magnetic field direction, and here Sailaja Prasad, thank you so much. So here you can observe one thing. So here you can see the magnet. So around the magnetic field, around the magnet, magnetic field will be there. So magnetic field will be from north to south. So the magnetic field start from north and merge at south. So emerge out from north and merge at south pole, emerge at emerge out from North Pole and merge at South Pole. The magnetic field will be around the magnet. So here in the form of field lines. The field lines. So field lines will start from North and merge at South Pole. Okay. So these field lines are closed loops. 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 Okay. These field lines never intersect. These field lines never intersect. If these field lines intersect, so if these field lines intersect, so what happens? Compass should show at a time two directions where it is not possible. Compass should show two directions at a time where it is not possible. So point number one, these field lines are closed loops. Point number two, so it is emerge out from north, merge at south, emerge out from north, merge at south, emerge out from north, merge at south. Third point is, so these field lines never intersect. If it is intersect, so if these field lines intersect, so what happens? At a time, compass should show two directions where it is not possible. Compass should show two directions where it is not possible. Okay, so this is about the magnetic field around the bar magnet. The magnetic field around the bar magnet diagram. So you can use 5 lines, you can use 7 lines, you can use 9 lines. Okay, whichever the diagram is preferable to you, you can draw. Okay, whichever the diagram is easy to you, whichever diagram is okay, so you are referring, so you are preferring and you are considering, you can take it, you can select one diagram and follow the diagram. Okay, so it depends. Okay, so I prefer 9 lines because 3 lines above, 3 lines below, so middle 3 lines, so it looks good. At the same time, that's your choice. You can take any one of those, any one of these 3 diagrams. Okay, so while drawing in the exam, so that's fine. Okay, so 3 points once again. Magnetic field lines are closed loops. Magnetic field lines are closed loops. Emerge out from north, merge at south. Emerge out from north, merge at south. Okay, so these field lines never intersect. These field lines never intersect. If it is intersect, so the point of intersection, at the point of intersection, compass should show two directions where it is not possible. Where it is not possible. Understood? So this is about magnetic field around the bar magnet. Magnetic field around the bar magnet. Yes or no? So next one we will discuss about loop. So we'll discuss about loop if the current is passing through the conductor. As I said in the previous concept, if the current is passing through the straight conductor, if the current is passing through the straight conductor, the magnetic field will be produced. Yes or no? The magnetic field will be produced around the current carrying conductor. Yes or no? If the current is passing, so now you can see here, if the current is passing through the conductor, so very important, if the current is passing through the conductor, So I'm taking this is the conductor. This is the conductor. Yes or no? This if you take the conductor, current is passing this direction. Current is passing in this direction. So thumb, right hand thumb rule. If you are taking the right hand, so thumb shows along the current direction. Thumb shows along the current direction. Curly fingers, folding fingers, wrapping fingers, curly fingers, folding fingers, wrapping fingers shows the magnetic field around the conductor. Magnetic field around the conductor. So if I am taking, if the current is passing downward direction, so if you consider current is passing downward direction, the magnetic field will be clockwise direction. The magnetic field will be clockwise direction. If the current is passing upward direction, the magnetic field will be anti-clockwise direction. The magnetic field will be anti-clockwise direction. Yes or no? If the current is passing in the conductor, if the current is passing in the conductor, if the current is passing in the conductor, okay, so the magnetic field can be identified. The magnetic field can be identified. Okay, if the current is passing in the conductor, okay, by using right hand thumb rule, we can identify the magnetic field. We can identify the magnetic field. Okay, so now we can see that is about current passing through the conductor. So magnetic field will be around the conductor. So magnetic field around the bar magnet, and if the current is passing through the straight conductor, magnetic field will be there. So these two we discussed. If I am taking the loop, so now I am considering the loop. Okay. So here, this is the loop. So positive terminal, negative terminal, current is passing like this. Current is passing. So around the conductor, the magnetic field will be there. Around the conductor, the magnetic field will be there. So here you can consider, I am taking like this. Okay, so when we are taking extension like this, this is north and this is south. Magnetic field will be moving out, 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 moving out. So magnetic field is moving inside, like this. Sir, how can you identify like this? So by using right hand thumb rule, we can identify the magnetic field around the current carrying conductor. By using right hand thumb rule, we can identify the magnetic field around the current carrying conductor. So this is north, this is south. Okay, so when you keep on this ring, this magnetic field is keep on increasing at the middle it will become straight lines. So in the middle you can observe, in the middle the magnetic field lines are parallel lines. The magnetic field lines become parallel lines. Okay, here, so one magnetic field will be added up to another magnetic field, another magnetic field will be added up to another magnetic field, like that keep on adding to the next magnetic field. So then the magnetic field will be more at the center than at the circumference. The magnetic field will be more at the center than at the circumference. Very, very important. Very, very important. Magnetic field will be more at the center than at the circumference. So this is about the loop. Next one, solenoid. So we are taking the solenoid. So till now we discussed about straight conductor. If the current is passing through the straight conductor, So now take a straight conductor. So wrap in the form of cylindrical shape. Wrap in the form of cylindrical shape. So I'm wrapping like this. So here current is passing. So around the loop. So magnetic field will be created. So magnetic field will be produced. Magnetic field will be there around the conductor, around the current carrying conductor. So how it will be? Here I am taking 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. So 3 above. Okay. So now you can see this is the magnetic field around the current carrying loop. So solenoid, we can say this is solenoid. Solenoid. So here around the current is passing through the solenoid, magnetic field will be produced around it. So direction is very important. So from north it should leave, to south it should reach. From north it should leave, to south it should reach. Okay, so this is about solenoid. So it acts as the same as like a bar magnet, same like a bar magnet. But here the difference between bar magnet and solenoid is, so bar magnet and solenoid here. In bar magnet, the magnetic field is fixed. In bar magnet, the magnetic field is fixed. But in solenoid, magnetic field is not fixed. We can change by changing the battery, and if you change the number of loops, if you change if you add one more cell, so like if you are increasing strength of current, if you increase the strength of current, If you increase the strength of current, automatically, so magnetic field will be increased. And one more thing here, so in the bar magnet, the magnetic field is fixed. We can't change the bar magnet magnetic field. So here poles are fixed, bar magnet poles are fixed. Here poles can be interchanged by interchanging the polarities of the battery. We can interchange the poles. We can interchange the poles of the bar magnet. Okay, so solenoid, we can interchange the poles of the solenoid. If you change the battery polarities, automatically poles can be interchanged and the strength can be increased by passing the strength. So more current and the number of loops. If you increase the number of loops and increase the strength of current, automatically magnetic field will be increased. But here magnetic field is fixed, strength will be fixed, poles will be fixed. Okay, so here whenever we want to magnetize, whenever we want magnetism, so we can connect the battery, automatically it act as a magnet. So if you are if you remove the battery, it won't act as a magnet. Okay, so this electromagnet, this one is electromagnet. Okay, so thank you so much. This is about solenoid. This is about solenoid. Next one now we will discuss about current carrying conductor placed in the external magnetic field. Current carrying conductor placed in the external magnetic field experience the force. Current carrying conductor So here I am considering current carrying conductor placed in the external magnetic field. Current carrying conductor placed in the external magnetic field. So to all my students, I am requesting one thing. I'm trying my level best to reach you all, teach the concept. Okay. So if you like the content, if you like the channel, please support to me. Okay. So I am doing my level best to reach you all, teach you all. So if you are interested, if you are willing to join, you can join to my channel as a member. At the same time, super thanks is available, super chat is available, super stickers are available. Okay, you can join if you like the content, if you like the channel, if you like my explanation. And I want to give one point, that is whatever I am doing this type of activity or teaching style. Okay, so these all are I'm doing to know to reach you in a better way, so to teach in a different way, in another way. Okay, so different point of view. So my point of view I'm teaching. So if you like the content, if you like my explanation, please do like, share and subscribe to Student the Brand. And please support my channel. So that's enough. That is what I want. So please support my channel. So thank you so much. Those who are supporting, those who are encouraging, those who are supporting me. So thank you so much for your continuous support. I'll take it. Okay, now current carrying conductor placed in external magnetic field. Current carrying conductor placed in external magnetic field. So a current carrying conductor placed in the external magnetic field. Okay, done. So a current carrying conductor placed in the external magnetic field experience the force. A current carrying conductor placed in the external magnetic field. So this is the external magnetic field, this is the conductor. So current is passing, it acts as a magnet. Thank you, Star Dolphin. Thank you so much for supporting. So okay, current carrying conductor placed in the external magnetic field act as a magnet. Okay, so this also act as a magnet. This one act as a magnet. So that is placed in the external magnetic field. That is placed in the external magnetic field. Okay, so if you place one magnet near to the another magnet, definitely the force will act on this conductor. The force will act on the conductor. So the conductor will move. The conductor will move. In which direction it will move? By using Fleming's left hand rule. 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 Okay, that is so index finger shows the magnetic field. So middle finger shows the current direction. Middle finger shows the current direction, and thumb finger shows the force acting on the conductor. Force acting on the conductor. Okay, here once again, so index finger shows the magnetic field, so middle finger shows the current direction, and thumb finger shows the force acting on the conductor. Okay, so Fleming's left hand rule, index finger, middle finger, and thumb finger. Okay, thumb finger shows the force acting on the conductor. So by Fleming's left hand rule, stretch three fingers perpendicular to each other. Okay, so this is about current carrying conductor placed in the external magnetic field. Okay, next one, live wire. Live wire is positive terminal, that is red insulation. Potential is 220 volts. And neutral wire is potentially 0 volts. Earth wire is potentially 0 volts. Potential difference between live wire and neutral wire is 220 volts. Okay, and that is about potential difference. And one more, we can take electrical fuse and earthing. Electrical fuse is a device which melt and breaks the circuit when when extra current is going, or it exceeds the minimum limit, or limit is placed on it. Okay, so if the extra current is going inside of the conductor, the fuse will melt or breaks the circuit. It safeguard the appliances. So earthing, any extra current is there, that will send to the ground. Okay, so that is earthing. Extra current for the metallic bodies, it will be there. So thank you so much. This is about magnetic effects of electric current. Chapter. So thank you so much for joining and attending and listening my class. So giving an opportunity to teach the class. Okay. If you like the content, just go and check my videos. There are many videos are there. There are many videos are there, so many different experimental videos or teaching methods I'm going. So I'm explaining different in different view, so in different style. So if you like the videos, please do like and share, and subscribe my channel and join to the channel. You can go for super thanks. Thank you so much for joining and attending. So this is your Shiva sir from Student the Brand.